Hey guys, welcome back. Today we're going to solve LeetCode's problem number 329, longest increasing path in a matrix. So given an integer matrix, we need to find the length of the longest increasing path. So remember that the directions we can move in are left, right, up, and down. We cannot move diagonally. So this would be an example. This would be the longest increasing path. So you can see that the path can go backwards, it can turn clockwise and both clockwise and counterclockwise. So I think what makes this problem so hard is that people think that there is some kind of smart or intelligent way to go about this so that you don't have to try all of the combinations. But actually it's just like that. You just need to go through each cell and try from every cell to start a depth first search that branches out through the cells of the matrix and tries to find a new maximum length. So the way we're going to go about it is, first of all, I'm going to store in a variable the possible directions in which I can move from a cell. So these are the deltas. So this is the delta row, and this is the delta of the column. Then what I'm going to do is I'm going to set up a base case where I'm going to say if my matrix is empty, then I just return 0 because I can't build any path. Then I declare a new variable max that stores the current maximum increasing path that I've found so far. And later on, obviously, I'm going to have to return this maximum variable. So now we need to compute and to update this variable to reflect what actually is the longest increasing path. So to do that, we're going to have to loop through all of these cells and start a depth first search from all of them. So the way to loop through each cell in a matrix is to loop through each row, done like this, and then loop through each column, like this. And now I'm going to have to update the max variable with the mathematical maximum between the max variable and an expression. And my expression is going to be my depth first search, starting from this row and this column, the current cell. So our depth first search function is also going to have a third parameter which represents the value of the previous cell in the current path that we are exploring. So since right now we are not exploring any path, the third parameter is going to be minus infinity, meaning that any value that we find is okay, we can consider that to be increasing because there's nothing before it. So it's always increasing in a way. So now we just need to implement the Dfs function. So that's going to take in the row and the column and the parent. And what I'm going to do is I'm just going to return 0 if my row and column are out of the boundaries of the matrix. So these are the conditions. The row is negative or it's greater than the matrix length, or the column is negative or the column is greater than the amount of columns that there are in a row. Now there is a third condition that I can use to return 0, and that's if the current cell value is less or equal than the parent. Because if this condition is true, then what happens is that the path that we are visiting with this depth first search is not increasing because the current matrix value is less than the previous, the parent. Okay, so now that we have this out of the way, what we can do is instantiate a max path from this cell. So initially it's going to have the value 0, and later on we're going to have to return this. And now we just simply loop through all of our neighbors and we start a new depth first search from all of our neighbors. So this is how we use our directions array here. So for every delta row and delta column, we add it to the existing row, just like this, and we add it to the existing column. So what this formula is doing is the maximum for this current cell, this node of the matrix, is 1 plus the depth first search of row plus the delta row, column plus the delta column. So these two things are going to essentially go through all of our vertical and horizontal neighbors. And this is just our current value. So this is going to be used as our third parameter for the depth first search function. So now the current cell becomes the previous cell for the next depth first search calls. And so then what we do is if we have found a path that is greater than the current max path, we update the max path with the greatest path that we have found so far. And then we just return the path. So this would already be working, but the time complexity would suffer a bit from the fact that when we call this depth first search here, we don't have any checks in place to prevent the same depth first search from happening later on, like here. So what we can do is prepare a memo. So this is going to be a two-dimensional array filled with empty arrays. And when we run a depth first search in a cell, we memorize the value that is going to be returned in this memo so that we don't have to do that same depth first search again. So what we need to do is check if the memo of this row of this column is defined. So if it is defined, return the memo value. And now we just need to remember to update this value whenever we return a value from this function. So the way we can do this very rapidly is to just return the assignment, because the assignment returns the right value of the expression, of the assignment expression. So that's it. We can submit the code and verify that it does indeed work. And that's it for now. So bye. Thank you.